Okay, so this worksheet was all about using the distributive property when we would FOIL. Okay, so if I wanted to multiply x plus 4 times x plus 2, so it's two binomials, and I want to do the product of those two binomials. Okay, so again, FOIL, this stands for first, outside, inside, and last. Okay, it's talking about my terms. So my first term, I'm going to take x times x to get x squared. My outside terms, it's going to be x times 2 to get 2x. My inside, 4 times x, so 4 times x to be 4x. And then 4 times 2 for my last to get 8. I can combine these together to get 6x. So my final expression is x squared plus 6x plus 8. Okay, so that's using our distributive property, or you might hear me say FOIL it out, use FOIL to essentially multiply our two binomials together. All right, now these are expressions. Okay, there's no equal sign, there's no equals, it's not an equation. Okay, these are expressions. These are just rewriting them in a different form. Okay, x plus 4 times x plus 2, if I chose x to be, say, 3, and I put 3 into my new quadratic that I formed here, x squared plus 6x plus 8, if I put 3 in there, I'd get the same answer. Okay, so these are just expressions. And so that worksheet was working through multiplying these binomials together. All right, now we're going to use that idea to get into factoring. Factoring is kind of the reverse of FOILing. So FOIL, we started with two binomials and we end up with a quadratic. Factoring, now we're going to start with a quadratic, and I want you to factor it into the product of two binomials. Okay? So what we're going to do is simply rewriting an expression as a product of its factors. Factors, this means multiplication. Okay? If I looked at the number 10, the factors are 1 and 10, but I can also do 2 and 5. Okay, what can I multiply to get to 10? Well, we can do that now with quadratics as well, and they come out to that form of two binomials that we multiply together. Okay, so we are going to factor quadratic trinomials. So trinomials means a three-term polynomial. Quadratic polynomial or quadratic trinomial would be ax squared plus bx plus c, and that's what we've been working with. All right, so a quadratic trinomial from standard form, which was that right there, into two binomials. So these two sets of parentheses. Binomial means we're going to have two terms in there. So depending on the variables, we're going to have two terms in each set of parentheses. So we're going the opposite direction of that FOILing. Now I'm going to give you a quadratic. We're going to rewrite it as a product of two binomials. Okay. Now let's actually factor one. So our final answer here, it's going to be a product of two binomials. Now, I do this a way that I'm comfortable with, I guess, the way I've trained my brain to do it. Mr. Mitchell might do it a little bit different. Miss Johnson might do it a little bit different. Miss Nebor, if you have her for Algebra 2B, might do it a little bit different. Okay. What I do is I draw this big X. I call it a cross. Okay, I call it the cross method. In the top of my cross, I'm going to multiply a times c, because remember, this is ax squared plus bx plus c. So in the top of my cross, I fill in the product of a times c. So in this case, A would be 1, C would be 8. I would fill in 8. In the bottom of my cross, I am simply writing my number here, which is 6, and it's my B term. All right, so the top of my cross, I put the product of A times C, and then the bottom, it's simply the B term. But I'm trying to think now, when I do my cross, I have this 8 and I have this 6. This 8, I'm thinking two numbers that multiply to get 8, and then also two numbers that add up to 6. Okay, and they got to be the same numbers. So again, I'm trying to think of two numbers that I multiply, I'll get 8, but when I add those numbers together, I only get 6. So this is doing math. You got to start rolling numbers around in your brain, thinking of what numbers will work that I can multiply to get 8, but add up to be 6. What would those two numbers be? Okay, I could have 4 and I could have 2. So I use that to fill in the right and left side of my cross. I could have wrote 2 then 4, 4 then 2, it doesn't matter. Okay, because we're going to be multiplying. Order is not important when I multiply. Now from that, I can immediately go to fill in my two binomial will be x plus 4 and x plus 2. And they're plus because it's a positive 4 and a positive 2. If it was a negative 2, it would have been x minus 2. Okay, so here is my factored form. And I can always check. If I were to FOIL these two binomials together, I would end up with x squared plus 4x plus 2x plus 8. These combine to become 6x. So x squared plus 6x plus 8. Yep, that checks out. That's exactly what I started with. So when you're doing this, when you find these two sets of binomials, do a quick check, multiply them out, make sure it gets back to the quadratic you started with. If it doesn't, that tells you right away you made a mistake somewhere, you can go back and fix it. Rather than happening on a test, you don't check it and it gets marked incorrect. Okay, so this cross method is the method I use for factoring. Okay, take my A and C, I multiplied, I put on top, and then my B term goes on the bottom, and then I'm thinking in my mind, I'm actually doing math. Okay, what numbers multiply to get my top number, but add to get my bottom number. All right, let's do another one. All right, I'm going to draw my cross. I'm going to put 20 on top and 9 on the bottom because really it's 1 times 20. Okay, so do not get in the habit to think it's always your C value that goes on top. It's A times C, but in this case it was just 1 times 20. Okay, trying to come up with two numbers. I multiply to get 20, but add up to be 9. Ben, what do you got? 5 and 4. All right, 5 and 4 I fill in there. I can automatically jump to say x plus 5, x plus 4, and I'm done. Okay, and I could do my check. I could multiply these back out. This one I know is correct. This one will work. Okay, so that cross method helps keep you organized, kind of gives you a roadmap of what you need to do to find those couple numbers that you need. Now, if you have one that starts out with a negative x squared, so this negative is not to be ignored in front of the x squared. But we're trying to factor. So let's factor -1 from every term. So I could write this as a -1 I've factored out. So now this is just x squared. Okay, I'm going to start a parenthesis. Because if I take negative 1 times x squared, I'm right back to where I started, negative x squared. So it's equivalent. I haven't changed it. I'm just rewriting it differently. But now I want to get a positive 13x. So this in here needs to be negative 13x. Because I'm going to multiply it by negative 1. That will get me back to my positive 13x. And then this becomes a positive 12 now. So that's how we can factor out a negative. Even if the number's not negative, we can still factor a negative out of it. Now, all I need to do is factor what's inside my parentheses. Okay, so a times c, my a is 1. So that's going to become 12. That adds up to be a negative 13. So two numbers I can multiply to get 12, but it has to be a negative 13. Brixton, you got it? What is it? You're on the right track. Think of positives and negatives, though. There you go. Negative 12, negative 1. Okay, so just because it's a positive value on the top, we can actually have two factors that are negative, because when we multiply those together, we get positives. All right, so now my parentheses become x minus 12 and x minus 1. But then do not forget about this negative 1 that we already factored out. All right, do not forget about that. So my final answer, final factored form, would be a negative 1 times x minus 12 times x minus 1. If you wrote it as just a negative on the far left rather than negative 1, either way I'll accept. Okay, but if you want to write it as negative 1, just to remind yourself that you factored out a negative 1, that's fine. Okay, so that would be complete factored form, getting it out. And then we could FOIL this out, multiply it all by negative 1, and we get back right where we started. Okay. All right, next thing we're going to talk about is the greatest common factor. All right, so greatest meaning largest, common factor meaning a multiple that we're working with. The greatest common factor, the GCF, is a common factor of the terms. The greatest means the greatest coefficient. Okay, so whatever you have times your x, or it doesn't have to be times x if it's your c value, and the greatest exponent. Okay, so if I had something like, let's go 2x to the 4th plus 8x to the 6th, and we'll go plus 10x squared. All right, if we had something like this. This is not in standard form. Standard form would be descending exponents. This isn't even a quadratic, okay, because our highest exponent here is 6. So when it says the greatest coefficient, what's the biggest factor I have of all of these numbers? Just the numbers, not the exponents, just the numbers. What's the biggest number that's a multiple? Ben, what do you think? 2, okay? Because this, the only way to get this was 1 times 2. With this, I could do 1 times 8, or I could do 2 times 4. With this, I could do 1 times 10, or 2 times 5. 2 is a common factor in every single one. 1 is also a common factor, but it's not the greatest. The greatest, 2 is bigger than 1, so 2 is my greatest common factor. All right, so I could factor out a 2 from all of this. Again, I'm just rewriting it, but in a factored form. So I'm going to factor out a 2, and then I have just x to the 4th plus 4x to the 6th plus 5x squared. But then also it says, and the greatest exponent. So x to this x squared is really x times x. That's what x squared means. x to the fourth would be x times x times x times x. X to the sixth would be 6 of them. So what's the greatest number of x's that I could take out? That's common across all of them. 2. Okay? Because I have 2 here, I have 2 here, and I have 2 here. So I can actually take this and say, well, I'm going to factor out 2 x's. So 2x squared now is my true greatest common factor. And then now I only have an x squared for my first term, because I had 4 of them, and I've taken 2 of them already outside the parentheses, so I'm only left with 2 left, plus 4x to the fourth, because I had 6 x's. I took 2 of them outside my parentheses, so I only have 4 left, plus 5, and I'm not going to have any x attached to the 5, because there was only 2 to begin with, and I took them outside the parentheses. So on this, my greatest common factor would be 2x squared. But then written in factor form would be 2x squared times that in parentheses, x squared plus 4x to the fourth plus 5. All right, so greatest common factor, you can have variables and you can have numbers, and you need to get a combination of both if possible. Okay, so let's look at this one. And I'm asking, what is the greatest common factor? Can I factor an x out? No, because it's not in all 3 terms. I have 0 x's in 56, so it's not a common factor. So let's look at the biggest number that I could factor out. So let's look at factors of each. Of 4, I have 1 times 4, and I have 2 times 2. On 20, I have 1 times 20, I have 2 times 10, 3 doesn't work, 4 times 5, and I'm done. Can't go any higher than that. 56, I have 1 times 56. Can I do it by 2? 56 divided by 2 is what? 23. Can I do 3? Can I do 56 divided by 3? You guys all got calculators, Andy. You can use your calculator too. Oh, yeah, you're right. There we go, 28. Thank you. Good catch. I need my calculator up here. What about 3? Can I do 56 divided by 3? Yes. What's that? Bigger than 8. Tomas says it. Well, it's a decimal, so it's not a factor then. Okay? So I can't do it by 3. Can I do it by 4? What's 56 divided by 4? 14. Okay? And then I could continue on from there, but I can tell you right now that 4 is going to be my greatest common factor of all 3 of those terms. Okay? It's a common factor and it has to be the largest. So I can factor out a 4. I'm not going to factor any x out. And so I'm trying to rebuild 4x squared. So inside my parentheses, I'm just going to have x squared as my first term. I'm trying to rebuild 20x. So 4 times what gets me 20x? Well, that would be 5x. 4 times what gets me 56? That would be, and I want a negative 56, so this would be a negative 14. So I factored out the greatest common factor, 4, and then parentheses x squared plus 5x plus 14. Let's see if we can break this into 2 binomials. So 2 numbers that multiply to get negative 14 would add up to be 5. There are 2 numbers I can multiply to get negative 14, but add up to be 5. Avery. Perfect. 7 and -2. So this is going to become, again, the 4 just comes along. Don't forget about that 4 that we had on the outside. X plus 7, x minus 2. That will be our final answer. That is in factored form. And that idea of pulling out the greatest common factor is a key strategy. Always look for a greatest common factor. Okay, once you identify a greatest common factor, it makes the problem a lot easier for you. Okay, so always look to see if there's a greatest common factor on there. Okay, that's it. So page 221, got some textbook problems. And then pay attention here. This is the Algebra 1 tab for some IXLs. So make sure you're going into the Algebra 1 tab, not the Algebra 2 tab, and going to AA2, only to a 40. It won't take you that long. And then AA4 to an 80 will be a couple more that you need to work for. Okay, but for the most part, these are very straightforward, and even the textbook problems are pretty straightforward. So have till the remainder of the hour to continue to work on this. Have them ready to go for next class.